Such a lovely introductions. Good morning, everyone. Professor G. Jagdish, Indian Institute of Science, Sri Umesh Chandra, Director, India Energy Network, Professor A.S. Kesina, Director, RGIPT, Professor Vikram Jayaram, President, INSACE, and Dr. S. Shamashundar, Chairman, Workshop Organizing Committee, Managing Director, Pro SIN R&D Private Limited. And also Mr. N. Rama Mohan, Executive Director, Technical, NPCIA, and all the dignitaries present here and connected through the website. The esteemed delegates from industries, good morning to all of you once again. I'm Sukla Mistry, as introduction has already been given. First of all, I congratulate Indian Energy Network, Rajiv Gandhi Institute of Petroleum Technology, Indian Institute of Science, and Indian Structural Integrity Society for bringing on board all the stakeholders. And thank you for giving me this opportunity to be part of this event. In fact, I'm indebted to Mr. S. Kesina, who is always creating some kind of opportunities for me to come forward and meeting all of you. World energy landscape is evolving at a breakneck speed. Transitioning to clean energy solution, as you all know, that maintaining the available assets for highest level of output is a need of the hour. It is well said that protect your assets, protect your business. No one on this earth is unaffected from the impact of corrosion. And this impacts useful service, lives of our professions, positions directly and indirectly. The corrosion cost incurred on production of goods is finally passed on to the consumers. The corrosion is a menace that affects most industries worldwide, causing devastating impact to the global economy. Oil and gas industries handles various hydrocarbons, starting from cleanest hydrogen to the most corrosive streams. Impact of corrosion is very high in oil and gas industry, as associated failures may lead to loss of lives, reputation damage, environmental harm, and financial loss due to loss of contaminant. The theme of this workshop, Managing Corrosion Impact on Integrity, is very relevant in today's context, where pursuing availability of assets with full potential is inevitable. As the theme highlights two major aspects, managing and corrosion impact on integrity. In word of management consultant Peter Drucker, who said that what gets measured or can also get managed. First, we need to understand and assess the corrosion impact on integrity and then create a comprehensive plan to manage it. Measurement of corrosion impact on integrity is a starting point of all these things. Now, NACE International, NACE National Association of Corrosion Engineers. They have done an impact study. What is impact? Impact is international measures of prevention, application, and economics of corrosion technologies. This study, they have done it in the year of 2014 based on available data on corrosion study in various countries and published that particular report in March 2016. As per this study, the global cost of corrosion is estimated to be 2.5 US dollar trillion, and which is equivalent to 3.4% of global GDP based on 2013. By effective use of corrosion control practices, estimated saving is between 15 to 35% of the cost of corrosion, that is 375 billion US dollar, and saving would be to the tune of 875 billion US dollar annually on global basis. Companies across geographic regions and the industries consistently scored lowest on policy and performance measures and to some extent organization and stakeholder integration. As per the impact study for India, cost of corrosion could be mapped to three economic sectors. First, agriculture, that is 70%, approximately industry is about 26%, and services about 57%. Studies showed India's cost of corrosion is about 4.5% of its GDP, which is approximately 100 billion US, which is well above the global average. There are various kinds of direct and indirect costs that are incurred due to corrosion. Those are primarily replacement cost, over-design cost, preventive maintenance cost, shutdown cost due to contaminations of product, cost of efficiency loss, cost of product loss, collateral damage cost of safety, health and environment, and also market share, that's a branding cost to the company. Now the impact study revealed the cost of corrosion is huge and that's by the all stakeholders to control it. The threat of the corrosion never stops, but its scope and severity definitely can be lessened to ensure the assets. Thus, management part of the corrosion impact on integrity has vital role in ensuring business continuity. An integrity management system is needed to mitigate such threat. Broadly, there are two different ways for reducing the corrosion control. One is the methods based on technology, which we can call it as a corrosion engineering, and the parallel to be done so is a method based on management, which we can call as the overall corrosion management. Further, in addition to this protection, protective coatings, safety measures primarily applied in the refineries and elsewhere to adopt the corrosion control. Now, some of the corrosion control measures which we do worldwide is a comprehensive national strategy for corrosion control, considerations to control corrosion at the design stage, decisions of material selection based on the life improved and alternative material available. Plant operation within the integrated operating window, which also called IOW in short. Use of online corrosion monitoring for taking preventive action. Also use of latest technology available like IIoT data analytics to predict the likely damage potential and the areas for adoption of proactive disseminations across industries and sharing the best practices and lessons learned across the corrosion communities through various conference, conclaves, and meetings. These are the ways. And also at the same time, we can utilize a database on cost of the corrosion for monitoring the impact of the entire corrosion control measures taken and the output and the benefit obtained out of them. Now, this is as far as the corrosion overall perspective is concerned across the globe. Now, as an Indian oil, what we do at our Indian oil. So let me speak about something on how Indian oil, the entire in terms of corrosion and corrosion control measures. In the refineries, we take the crude into the system and which comes primarily imported or primarily from the wells in the country. And this is all coming through pipelines. So this crude is not visible to the people who are operating the plant. We take the crude from the system through pipeline, it comes into my refinery plant and processed through different process plants at a high temperature and pressure. And then finally different products come. Different products I mean to say diesel, petrol, ATF, LPG and all other products. And it goes to the retail outlet through pipeline and on the process of entire thing we are not able to see anything technically. And the final product which we produce, we are able to see at the retail outlet where the car is filled with the fuels or your two-wheelers or the three-wheelers are filled, fuel. That is the time when you can see. So the entire operations are dependent on completely on automations and instrumentation. So it is so critical and the entire process, the entire product process materials, starting from crude, HSD, diesel, hydrogen, sulfuric acid, hydrochloric, so many chemicals are being utilized in the entire process. It is highly corrosive and the temperature of the entire process goes as high as I would say 1000 degrees centigrade and the pressure is also goes as high as 250 kg centimeters square. So severity of the plant operation in the refineries are very very critical, and if any drop of product comes out due to corrosions or the leakage or the weak point in the plant is from there, that can cause a huge leakage and huge havoc in the system. It can cause a disaster in the entire environment. So that's a criticality of the refinery. And I understand that after nuclear plant, the most hazardous operation is the refineries. So that's a criticality of the refineries. Now I would broadly say what Indian Oil's nine refineries are containing. It contains more than 19,000 kilometers of cross-country pipelines. Pipelines means all across the country, wherein products and goods are moving from one refinery to other refinery, one terminals to other terminals, as well as from one aviation terminal to other aviation terminals to distribute the product from one point to the other point, as well as receive the crude from one source to other source. Now, it has got also 60,000 marketing touchpoint. A marketing touchpoint I mean wherever the materials, the fuel products is available. It can be the ROs, which can be the terminals, which can be the LPG bottling plant, and all these distribution marketing touchpoints are there, and we have a huge network to take the product to reach into the every part of the country. Now, if I talk about refineries, we have nine refineries, and this refinery deals with more than 20,000 static equipment. Static equipment means we, in the refinery terminology, we call it as heat exchangers, vessels, columns, and light base. And hot and sphere tanks, these are called static equipment. And we also handle more than 30,000 kilometers of pipelines. If you see the refineries has got huge pipelines, and the product or the intermediate products are moving from one end to other end of the entire refinery. As I already said, that nothing is visible, but every processing is going on in the entire system. And we have also almost more than 26,000 rotary equipment, that is pumps and compressor and etc. So many equipments are there, and the asset or the integrity of this equipment maintenance is very important. And these equipments are subjected to critical processing conditions and handles very critical material like hydrogen, then sulfuric acid, hydrochloric acid, high sulfur crude, low sulfur crude, and many H2S and many chemicals which are really very corrosive in the system. So on the day-to-day basis in the refineries, we actually handle 2,500,000 metric ton of liquid hydrocarbon as an inventory. And this equipment inspection, for the same reason as I already explained, that this equipment inspection and the maintenance is the utmost importance of a continuous operations with 100% reliability, very high level of reliability. So reliability of the equipment is very important. There are two kind of failures in the refineries. One is the process failures that comes from the operation part, and another is the equipment failure. The primarily we have seen the equipment failure is very high in the refineries level, not only in India, not in other places too, because this handles many things. It handles pressure, temperature, it handles very high level of corrosivity in the entire system. So corrosion management strategy for the Indian oil refineries are very important, and it is it has evolved actually over the year. And lot of technology, lot of instrumentation has come up over the time. So, and Indian Oil has a robust system in place for inspection and maintenance of these assets. And this system, some of them I would like to share with you, is first we do the identification of corrosion threat, where from it is coming and which are the areas where we really analyze that what are the reason, what are the area which is really is the corrosion taking place and it becomes a threat for the operation of the plant. And we also do life cycle cost analysis in decision making and also what are the kind of method to be used in the design stage. And similarly, the development of corrosion control strategy based on all this study is to be done that what are the corrosion control measures in the entire system. That there should be a detailed action plan on this subject. That which are my critical areas where the corrosions are more and where the critical in terms of operation and along with the corrosion. And then we have to identify the elimination and reduction process by the operational control and the material selection. The material selection is primarily done in the design stage. So in the design stage, we take care of many of the corrosion control over there itself. But during the operation, some of the things, even if you have high level of metallurgy, and when you do the economics at the design stage, maybe you need to do some of the corrosion control measures during operation to see the economics of the metallurgy is to be selected in the highest level, or you need to do some kind of continuous corrosion monitoring system during the operations. So during the operations, sometimes in many cases it become quite economical. So to do so, there are processes. There are processes we do inhibitions by neutralizers. That is called corrosion inhibitor. I know, and many of you may knowing that we have implemented comprehensive corrosion control system in our plant. And the corrosion in the top of the your distillation fractionating distillation column, because H2S and hydrochloric acid is generated, so it comes at the top. So the overhead system, we call it as top portion of the fractionating or distillation column. Then comes condenser. Then come your knockout pot, and all these things has got a severe area for corrosion. It is a sustain to the severe corrosion. So we are injecting neutralizer like amine or the ammonium hydroxide to neutralize all the acids, H2S and hydrochloric acid, which is generated in the system. So we call it as inhibition by neutralizer or corrosion inhibition. And then comes protection by providing coating barrier or cathodic protection. So you know all the cross-country pipelines which is running underground from one portion of the country to the other portions of the country. These are all cathodically protected. So it has got coating, external coating, and it has got also cathodically protected. So within the refinery also, the entire piping network are externally painted, and these days the very improvised painting material has brought out by the different painting companies, and they are giving a very good services to the tune of sometimes 7 to 8 years. And every refinery is having a rolling plan for the painting, which are implemented in all the refineries at a particular time. So, like we have 9 refineries, out of which the Paradip refinery and the Haldia refinery, they are, located in a very corrosive area. It is coming in the highly corrosive area of the country. It comes in the, I think, corrosion rate is something to the tune of 4 to 6 mils per year. MPS, what is it called, per year. So these areas we have a rolling plan in such a way that every 3 years the entire pipelines externally to be painted. Pipelines and entire piping systems and also the equipment to be painted. So that will give you external protections of the pipeline. And some of the equipments are there which are susceptible to the internal corrosion due to the material content in it. We are doing a lot of lining and internal painting. So these protections are this coating barrier is having two types. One is external, another is internal too. Now we at IndianOil using the means of available to utilize its assets fully by implementation of the corrosion management strategy, and we also implemented RBI, risk-based inspections, wherein your inspections has to take a strategy. You will see that failure is taking place primarily by 20% of the equipment, and 80% equipments are not coming into the critical zone. So we need to do get the focus onto this 20% of equipment. So risk-based inspections will provide you that what are the 20% equipment which is a cause of concern. So that 20% equipment has to come into the critical path, and you need to monitor the entire 20% equipment at a certain frequency, and although the 80% equipment will be also taken care of, but 20% will be in the most focused area. And newer technologies like IIoT, AIML, these are the technologies which are already under implementation in various locations. And in today's scenario, you see all the refineries are utilizing drone. Drone is one of the systems which are very important, which are being used in almost all the refineries, because when we do the inspection of various areas, it is really practically not possible for people to go climb into the very elevated area like flare stack, then stack of the captive power plant or stack of the heaters. Many times it is not possible to you ride into that and go inside the stack to inspect it. In those cases, the inspection by using drone is very has become effective. And these days, most of the equipment where critical areas where it is not accessible for the inspection engineers to go, drone has really supporting us for inspection of those areas. So these are the technologies are coming, and another technologies we have implemented in our refineries is called augmented reality and virtual reality. You can do your repair. Suppose you require technical assistance from a OEM, and the OEM is not available immediately for your to give the support. You can utilize your air wear method over there. So you can put that air wear helmets, take the support of OEM who is sitting long at long distance, and you can utilize them to do the repair, replacement, or necessary corrections in your equipment. And these days, this AI system, the technology is being hugely utilized in all our refineries. And another methods are which everyone is doing is shutdown monitoring or turn down refinery turn down shutdown. You know the shutdown is basically a fair for the inspection engineer. A fair in a sense. The shutdown actually is a time when all the equipments are open and all the inspection engineers are able to see the conditions and the health of the equipment in his own eyes and utilizing by various tools and tactics. So this monitoring of this equipment during this time, assessing the health of the equipment during the shutdown time is very important, because when you are carrying out the inspections in your plant, you have to take care to few things. That what are the things require immediate repairs and replacement, so that you are able to run the plant without any kind of failure for the next 4 to 5 years. So you require your experience, you require critical inspections very meticulously, you require to utilize your tools and tackles in all the unaccessible area, also to ensure that everything has been actually checked, and everything, all these health conditions has been identified, and whatever actions to be repair replacements to be done in this shutdown, you need to do, and whatever replacement is to be done for the forthcoming shutdown, next shutdown after operation of 24, 20, after operation of 4 years, you need to be ready for this. So your recommendations also has to come, so that because once you give the recommendation, availability of the materials requires certain time, because you have to order and the material has to come. So the shutdown monitoring is very important. Now to do better way, the shutdown monitoring tools are being extensively utilized. So that also we are doing in the refineries. Now at the cusp of this energy transition, we need to be very future ready with the new forms of energy, as well as ensure highest performance from our existing assets. You know that this energy transition, one of the parameters is we call it as energy um, uh, energy EII, intensity index. Another is called MDL. These two parameters is talking about that how much energy actually efficiently you are utilizing. So plant should run with highest level of operational excellence and reliability, and that will give you a lot of energy saving from the plant, and that is the today's requirement. Fuel is required for the country's demand. Fuel is required, but for the current situation, the way the energy transition is taking place and the way energy demand in the country, our country is increasing, it's utmost need for all the refineries to run the plant at a highest level of energy savings. So for energy saving, one of the primary requirements is to have minimum interruptions and maximum level of reliability of the equipment. And to do so, this corrosion group or the inspection group has a very big responsibility to keep there to do the very meticulous inspections by themselves, by upskilling their knowledge, by having trainings, by utilizing modern tools and tactics, so that all the equipment runs with a highest level of efficiency without any kind of interruptions, so that we are able to really save energy in the fullest extent. And that will give a great help, particularly in our country, where demand is very high and energy saving requirement is very high, so that we are ourselves we are up into this energy transition situations. So we need to improve the margin and control the loss with effective utilization of our assets without compromising the reliability and safety. So amidst energy transition, the challenges and the opportunities demand the rapid adoption of the best practices is the best challenges at this moment. Hence, this workshop, Managing Pollution Impact on Integrity, is a well-timed event. As we all know, and all experience sharing among the stakeholders has been the key method of learning and quicker adapting the best practices is to be done by each and every person sitting here and all across the country. I am sure the deliberation and discussion held here will benefit all the stakeholders. And thank you very much for giving me this opportunity. And I am sure this particular program will come out with a lot of takeaways, which all these participants will be taking through this conclave and will help in their own areas of work, particularly in the refineries and all other critical areas. Thank you very much. Thank you very much for giving me this opportunity. And best of luck to the entire team participating in this, and best of luck to the organizing team. And my best wishes to the organizing team. So thank you very much, Jai Hind, Jai Bharat.
Thank you very much, madam.
Thank you very much.